Okay, so this is just quick summary of what we talk about it. So we have the GHRH release from neural cells of the hypothalamus, and this hormone binds to endocrine cells in the anterior pituitary, and it stimulates the release of growth hormone from the endocrine cells into the systemic circulation. And again, what we are seeing is we have the GHRH being released from the hypothalamus, which then binds to endocrine cells in the anterior pituitary. And these cells then release GH, the growth hormone, into circulation. And it travels to different cells in our body to stimulate protein synthesis and cell growth. So this GH growth hormone, and as you can see, I have problem talking this word because English is not my first language, but here we go. Growth hormone. So this hormone is non-specific in its action. There is a something called the pituitary gigantism, which is a rare condition that occurs if GH, we have a hyper secretion of this hormone that begins in childhood before the closure of the epiphysis. So that's a rare condition, and it occurs due to the hypersecretion of this hormone. So the next hypothalamic neural hormone we're gonna look is the TRH, the thyroid releasing hormone. This hormone is released from the hypothalamic neurons into the blood. It stimulates the release of oh my God, thyroid stimulating hormone, TSH. So it stimulates the release of TSH in the anterior pituitary. So the TSH then enters circulation and it stimulates endocrine cells within the thyroid, and it stimulates the release of thyroid hormones, which are important in metabolism. Among the thyroid hormones, we have the hormone, a hormone called T3 and another one called T4. Those hormones are involved in metabolism. They promote the mobilization or release of fuels such as carbs and stimulate metabolism and protein synthesis. T4 is the thyroid hormone that is released more, but T3 has the greater metabolic effects on different cells of our body. Again, two important hormones that play an important role in metabolism. So the next neurohormones we're going to look at is the GnRH, the gonadotropin releasing hormone. So this hormone, just like other hypothalamic neurohormone, it revels down into the anterior pituitary. It binds to endocrine cells. It triggers the release of the LH and FSH hormones in our anterior pituitary. These hormones then stimulate sex organs to release hormones. In men, it triggers the release of androgens, and in females, in women, it triggers the release of estrogen and progesterone. So these sex hormones play a role in sexual maturation and reproduction. The changes in estrogen and progesterone are what triggers the menstrual cycle. It's also important in pregnancy and lactation. Also, that's pretty exciting if you're a female. Estrogen has cardioprotective effects. Isn't that super cool? So females have much lower risk of cardiovascular disease due to the cardioprotective effects of estrogen. And also, in the case of cardiac event, they have a better ability to recover. So that might be the reason why women live more than men. Um, it counterparts of the counterparts of these hormones in males are androgens, um, male sex hormones, and it triggers sexual maturation. So we have this testosterone like GH, but potentially is sorry. So testosterone like DH potentially stimulates cell growth. It make you bigger, faster, stronger. Um, but the reason, and that's the reason why steroids make you bigger and stronger. It stimulates cell growth and protein synthesis. It's also used by athletes to increase performance, just like GH. So if you are an athlete, don't take testosterone, don't take DH. It's totally illegal. So this was a study which shows you the effects of testosterone on muscle size and strength. So we have four groups where exercise. We have one group that exercise with, and one that is without testosterone, and another group that is no exercise with or without testosterone. Um, so these participants were administered at super physiological doses. They measure lean mass, size of different muscle, as well as muscle strength over bench press and squat tests. And this graph shows you increases in lean mass and strength. So regardless of if you exercise or not with the administration of testosterone, you increase muscle mass and strength. So these gains were greatest when testosterone was combined with resistance training. So there's no question about its effects on muscle and strength gains, of testosterone's effects on muscle and strength gains, but its effects are targeted on to skeletal muscle. So when you supplement, it targets many cells in your body, and you get several systematic effects that are unwanted. So those are some of the effects of those unwanted effects: deepening of voice, hair loss at temple, um, prostate growth. It activates skin glands. So there's tons of side effects of supplementing with testosterone. Okay, so next we have the next neurohormone we have is the corticotropin releasing hormone, CRH, which stimulates the adrenocorticotropic hormone, also known as ACTH, to be released from the anterior pituitary. It causes the adrenal glands to release hormones known as adrenocorticoids. And here is what it looks like. So we have two distinct parts. We have the cortex, which is the outer portion of our adrenal gland, and we have the medulla, which is the inner core of the adrenal gland. So these adrenal glands are located on the top of our kidneys. The ACTH hormone, it stimulates the adrenal cortex to release different steroid hormones. And we have three types of steroid hormones. We have mineral corticoids, we have sex hormones, and we have glucocorticoids. The mineral corticoids, we have aldosterone that plays a role in kidney function and water reabsorption. We also have androgens like testosterone that are released from the adrenal gland, and much fewer than released the um, from the testosterone. And we have glucocorticoids that releases cortisol. So let's talk about let's take a look at the cortisol. So cortisol is involved in the breakdown of protein. It frees up amino acids in our liver that can be utilized for glucose synthesis via gluconeogenesis. Cortisol also stimulates lipolysis. It frees up free fatty acids in our adipose tissue. So the good effects when you're fasting or exercising, you spare carbohydrate, you increase protein and fat metabolism, and mobilizing substrate and providing energy to cells for ATP production, which is great for exercise. However, chronic elevations in cortisol cause negative effects. So cortisol has an important systemic functions acutely, but chronically increased cortisol can be bad. So the chronic stress of cortisol can cause problems such as blood sugar imbalance, decreased muscle mass, lower immunity and inflammatory responses, and elevated fat storage. So in the adrenal medulla, we have the secretion of catecholamines, such as epinephrine and norepinephrine. And the release of catecholamines, it's under direct neural control. So we're gonna take a look in detail at this in the next class. So what we cover so far with the hypothalamus and the pituitary gland, those two organs are classic endocrine organs. They're known for a while that these organs release hormones which alter systemic function. And recently has also been discovered that other organs and tissues, such as adipose tissue, originally just thought as a storage for fat, and skeletal muscle, typically just thought to be important for contraction. So these other tissues also secrete substances into blood that bind to receptors on other cells and alter their function.